So today we're going to be learning the 3 states of matter. Okay, so what is the 3 states of matter? A lot of you will be asking me. Right now, I'm sure you've definitely heard these terms before. Okay, I'm going to give you 3 terms, and they are going to be the 3 states of matter. Okay, so the 3 states of matter, we have the solid state, the liquid state, okay, and last but not least, the gaseous state. Okay, so what are these states all about? Like, what am I even talking about, right? Okay, so firstly, we're gonna be like diving into each and every one of their sort of like, their characteristics, I would say. So whenever I talk about characteristics, I always have 4 different things. Okay, 4 different things that I think is very important for the characteristics piece. Basically, shape, volume, compressibility, and density. Okay, the 4 things I like to talk most about this. Okay, now these 2 are a bit more complicated, so I'm gonna go through them later. Firstly, let's talk about shape and volume. Okay, that's the easiest one. Now, let's define shape and volume first. What is shape and what is volume? Now, shape. I'm pretty sure you all know what's the meaning of shape, right? That's a super easy English word, right? Shape is basically, I don't even know how to describe it, but I'm pretty sure you know what shape. Now, if I'm going to I'm thinking of a highlighter from my table right now, and you look at it, there's an obvious shape to it. If, for example, my highlighter looks something like this, okay? I'm just going to draw it out. It looks like this, okay? My highlighter looks like this. This is sort of like the shape of a rectangle, agree? Sort of like the shape of a rectangle. So I'll say the shape is a rectangle. Okay. So just basically we are defining the shape. One of the characteristics of matter is the shape. And a lot of you will be like, what do you mean by the characteristics of matter is shape? So you're telling me, oh, a solid is definitely this shape. A liquid is this shape. Then I'm like, oh, solid, the shape is, let's say, a circle. If it's a liquid, the shape is a square. And if it's a gas, the shape is a triangle. Am I talking about that? No. I'm talking about whether it's a fixed shape or not. And what is a fixed shape? Okay, so when I say fixed shape, what I mean is, okay, let me give an example. If I have an object, I have a little box over here. Okay, I have a little box over here. Now, let's say I want to make this box turn into, this is a cube, alright? This is a cube. I want to make this cube turn into a sphere. Now, I don't know how to draw a sphere, 3D sphere, right? But then I'll make it look like a sphere. Okay, fine, cylinder. Let's make this better. Okay. I want to make it now look like a cylinder. Can I do this? Is it possible? Would you, if I have a cube right now, can you perform some magical powers and make it look like a cylinder? No way, right? Because this item, this whatever it is, has a fixed shape. It's just born to be a cube. You cannot twist it into a cylinder, right? So that's how we know. So when I'm talking about shape, I'm talking about whether it's a fixed shape or not. Okay? I'm talking about fixed shape. Basically, can you change it? Okay? So that is shape. Now, let's talk about volume. Okay, if I give you a cube which measures 3 cm by 3 cm by 3 cm. Okay? What is the volume of this cube? If you know your math, it should be quite easy. 3 times 3 times 3, which are basically just 3 cube. And that's literally why they call it cube, because it's like a cube. 27. So your answer will be 27 cubic centimeters. Right? Okay. So this is basically a volume. Now, if you want to give it a very easy definition, basically volume is the amount of space something occupies. Now, over here, if you look, I say the word matter. And what is even matter in the first place? It will link back, alright, it will link back. Matter is anything that has two things. Firstly, mass and occupies space. Okay? This is the definition. Mass and occupies space, not weight. Okay, mass and weight are different. Mass is basically how heavy it is. Weight is a force, alright? But that's not important for now. Basically, just you know about that. Okay, mass. Okay, a lot of people say take your height and weight, right? Wrong. Actually, you can't say take your height and weight. Basically, what they mean is height and mass. Okay, but that's not like a very nice way to say take your height and mass, right? It doesn't ring. So they just say weight. But scientifically, you cannot say height and weight. It does not make sense. Okay, because weight is the gravitational force. Okay, and no, you don't say that. Okay, mass is whichever planet you're on, it will be the same. But weight is defined by the gravitational pull in newtons on how strong the force is. So if you go on the moon, right, it won't be that strong. So it will be different, the weight, but mass will be the same every time. Okay, but doesn't matter. It must have mass and it occupies space. So now if we move back down to here, basically, if it occupies space, it has volume. If it occupies more space, more volume. More space, more volume. Okay. So that is basically the meaning of volume. Now, is there any way to change the amount of volume? If I have this cube, which is 27 cubic centimeters, can I change it? I want it to be super big. I want it to occupy a lot of space. I want it to be like 1000 cubic centimeters. Is it possible? No, it's not. So that is what we mean by fixed volume. Does this state of matter have a fixed volume? Okay, so now that we've learned exactly what is shape and volume, we can move to defining them in the three states of matter. Okay, so solid. This is actually the most straightforward one. Solid, does it have a fixed shape? Yes. Solid is basically just a hard object. It doesn't have to be hard, but most of the time it is. So, for example, just on my highlighter, right? I took a highlighter. This highlighter has a fixed shape. I cannot change it. So that is basically what solid is. Alright, I'm pretty sure you guys know what solid is. Okay, so it has fixed shape. Okay, you know what? Let's just I'm just gonna put a tick if it's fixed. I'm gonna put a cross if it's not. Okay. Now volume is a fixed shape. If you take any solid, there is no way that you can change the volume. Okay, but here's the thing that like a lot of people don't understand. Is a sponge a solid? Is a sponge a solid? Now, some people, okay, let's say you say yes, sponge is a solid. Okay, never mind. Let's just say you say yes, okay, because you won't say no, right? Of course, sponge is a solid. But a lot of people don't understand. But the problem is, sponge, it does not really seem like solid because you can like sort of squeeze it, you can sort of like crush it, you can stretch it. Okay, and that will affect the shape, agree? I could have a sponge, and I could make it and crush it to a very small size, and that will change the volume. I could make it have a weird shape if you like bend it around. Oh, okay, but that's because it's elastic. Firstly, because it's elastic. So that is literally why you can do that. And secondly, you may say, oh, you can change the shape, you can change the volume. So it's no fixed shape, no fixed volume, so it's not solid. But here's the thing, it actually is. Now, the only reason you can change them is because of these things called the air holes. And the air holes, of course, they contain air. And air is gaseous. So, gaseous and solid, they are two completely different states of matter, which is why they have different characteristics. But if you just look at the sponge itself without taking into consideration the air holes, which I'm not supposed to take into consideration because we're only talking about the sponge in this case, then the sponge is solid. Okay, so don't get confused with this sponge thing. Alright. Okay. Now So fixed volume. Now let's move on to liquid. Okay, this is gonna be an interesting one. Now, liquid is basically just sort of like those kind of fluid things. Okay, actually, gas is also fluid, but okay, like like water, like a can of orange juice. It's all liquid. I'm sure you know what's liquid, right? So, do liquids have a fixed shape? Hmm. Now, liquids actually don't have a fixed shape. I'll explain why right now. Okay, now if I have a little jar of milk and I pour it into this weirdly shaped jar. Okay, wait, sorry. I need the jar to be a bit more weirdly shaped. If I have this, right? And, okay, this is my jar of milk. Delicious, delicious milk. I'm gonna put it in this weird jar. I'm gonna put it in this weird, weird, weird jar. My milk probably will be like this, right? Now, if you're gonna extrapolate the shape of the milk from both jars, this jar, the milk is gonna look like this. This jar, the milk is gonna look like this. And I'm pretty sure you can see that this shape and this shape are different. So, liquids take the shape of the container they are in. Basically, if you have like a jar of milk, right, it won't have a fixed shape because if you pour it into different shapes, different jar shapes, it will be different. Okay, it will look completely different, which is why liquids don't have fixed shape. Okay, cross, but it's a fixed volume because if you think about it, can you change the volume of liquid? If I'm gonna put 100 cubic centimeters of milk into a jar and I pour it into another jar, it may have a different shape, but it will still be 100 cubic centimeters. Agree? So tick. Right, that's what gaseous. Gaseous is the most interesting. It's basically like air. And air, there's a lot of different types like oxygen, carbon dioxide, nitrogen, whatsoever. And a lot of crazy different types of air. So, do they have a fixed shape? I'm pretty sure this one is a no-brainer. If I'm gonna put a bag of air into like this potato chip bag, you know potato chips have a lot of air inside, right? And I have another container. Okay, this is potato chips. Okay, and I'll put them in another container that looks like this. The air will just take the shape of whatever is inside. This is sort of like a fluid. So this is cross. Now, does it have a fixed volume then? Okay. Now, you may think, oh, it does. But actually, it doesn't. Now, if I have a syringe, okay, I don't know how to draw a syringe, but I'll just draw it like this. Okay. And I put it air inside, and I'm gonna push this syringe in. I'm gonna fill it all with air, alright? It's all with air. All got air. Alright, what I'm gonna do now is I'm gonna push this syringe in. Push, push, push. Actually, I can compress this. I can squeeze it in. If you think about it. If I'm gonna have a syringe, like something like this, I'll take this and push it in, push it in. At the start, it is filled with air, but I'm gonna push it in. And now it's gonna go down here. This air can actually compress itself down. If I'm gonna fill it with a solid substance, let's say I'm gonna fill it with sand. Sand is solid. If I fill it with sand, you notice I can hardly compress it because it's so hard. It cannot be compressed. But if it's air or anything in gaseous state, I push it down, you realize that I can actually push it down a little bit because it can actually be compressed. So notice how I can actually change the volume of the air. Alright? So that is literally why air actually has a fixed volume. I mean, sorry, not a fixed volume. Now let's talk about compressibility and density. Now, actually, compressibility is very closely linked to volume. Okay, let me explain why. Now, compressibility is the ability to be compressed. Now, if this thing has a definite volume, has a fixed volume, can it be compressed? Let me ask you. If I have this box that is solid and clearly you it has a definite volume, can you compress it? No way, right? Even if you have like super strength whatsoever, you can't compress it. Okay, and don't tell me things like, oh, actually, right, if you have magical powers, you can. Don't tell me this, alright? By right, you cannot, alright? So I'm pretty sure you guys understand. So, if, as long as it has a fixed volume, it cannot be compressed. So I'll put cross over here. Now, how about liquid? Liquid is same thing. Fixed volume, right? So cannot compress. But gaseous can because it doesn't have a fixed volume, doesn't have a fixed volume. So we can actually compress it in a syringe whatsoever. So it can be compressed indeed. Okay, now, lastly, what is density? Okay, so density is actually sort of like how closely the things are packed together in a limited space, right? So, for example, okay, the units for density first are grams per this. It's sort of like the mass per unit volume. Mass per unit volume. So in this volume, the mass, in this volume, the mass. And it's sort of like how closely packed they can be, how tight they can be, right? So now I want to explain to you exactly why solids. Okay, firstly, which okay, is solid's density very high? How dense is a solid? Now, I will explain more about this in the kinetic particle model video, which I will upload soon. It's about the kinetic particle model of different states of matter. But I'll just give you a quick sneak peek. A solid is closely packed together, like this. Okay? And you can clearly see that it's completely packed together. Super little spaces. And that's exactly why it's so dense. That is literally how we call it, right? It's kind of hard to explain. But it basically means the mass you can get, how much you can pack inside this volume. That's why we say grams per, why do we say this? In this amount of volume, how much stuff, how much mass can you fit inside this volume? That's literally what it means. So, of course, if it's more tightly packed, it will be denser, right? So, in a solid, think about this. A solid, the kinetic particles theory, are the molecules are arranged in this way. They're so tightly packed together. So that's why solid is the densest. Okay, solid is the densest. So, how about liquids then? Liquids. Now, these molecules are held together by something called intermolecular forces. Okay, intermolecular forces. And if you just look at it, the root word is basically molecule. So, they're held by this. But when they're heated up to a liquid, they will slowly break apart. And slowly, they will like lose connection. There will still be intermolecular forces, but it will be weaker. So, thus, it will be packed a little bit more loosely. You can see gaps here and there in liquids. Lastly, we have gas. Now, gas is the one that is the least dense, and the most furthest apart. It's like super far away. You can like see like the intermolecular forces are so weak, you can like see not much connection, right? So that is why it's the least dense. So essentially, I will explain more in the kinetic particle model video. You can go and watch it if you want. You can learn more. It's a bit more advanced, but that is exactly why we can say all these. So highest. This is sort of like medium, and the density for gaseous is the lowest because of how far apart their lines are, like just completely just disconnected. Okay, so that is literally the three states of matter characteristics explained. You can go watch my kinetic particle theory video. I mean kinetic particle model, yeah, video if you want. You can learn more about exactly how the molecules are, you know, how they are shaped in a solid, liquid, and gas. Okay, but thank you very much for watching. Hope you like this video. Hope you learned something, and see you next time. Please consider liking and subscribing if you think this video was good, informative. Thank you very much, and goodbye. Peace.